At this station, we will see how a manufacturing operator on a connected work cell will receive updated digital work instructions to perform the assembly steps for the new valve and manifold assembly. During the procedure, the required torque range will be automatically passed to the connected tool, and the actual values will be recorded for real-time quality control. Field data had led to the redesign of the pitch manifold to accommodate a new valve which would perform better under the conditions being experienced in the field. An engineering change notice was created, and the design engineers have specified a new valve in the MBOM to be used in the pitch manifold assembly, as well as some modifications to the manifold block in the CAD model to support the new valve.
Once design engineering indicates their changes are complete, the change workflow assigns a task to manufacturing to begin their work. Manufacturing engineers can access the upstream changes and use the BOM compare feature to help them understand how these changes will impact their manufacturing strategy. Upstream changes to the EBOM need to be addressed by revising and updating the MBOM. Windchill's NPM link provides a powerful BOM transformer interface to maintain this digital thread of information, connecting multiple views of the BOM. Here we will tell the BOM transformer we are working in context of an enterprise change, and the system will automatically filter down the BOM to show only items specific to that change. Visual indicators alert the manufacturing engineer to items that have become out of sync due to upstream changes. As they revise the MBOM data to synchronize with the design changes, the system can automatically suggest what has changed and consume those changes in the revised MBOM structure. Once the changes affecting the manifold block, the new valve, and the new fasteners have been addressed, the MBOM data will be checked in. Since Windchill understands we are working in the context of a change, revisions to the MBOM are automatically added to the resulting items section of the change task, ensuring the digital thread of information remains intact. Changes to the MBOM lead to changes in the bill of process. Here's the bill of process or process plan in its release state prior to addressing the upstream changes. BOMs can be related to the bill of process, and BOM components can be allocated to the process steps. A bill of manufacturing resources can also be related, and resources such as tooling and fixtures can be allocated to the steps as well. Then this is utilized to create visual work instructions documenting assembly and fabrication requirements. Here we see the work instructions documenting the assembly of the pitch manifold prior to the change. Release process steps are revised as part of the manufacturing change task. Allocated components from the revised MBOM are consumed, and visual work instructions are automatically updated. Once changes are checked in, the work instructions are generated and reflect the design changes that started in engineering to address field issues.
Manufacturing completes their changes, and the workflow moves on to publishing new digital work instructions for operators to use in the assembly line for these new updated manifold assemblies. The operator at the assembly station uses a touchscreen monitor to bring up the ThingWorx connected work cell application. From there, he selects his work order and starts following the sequence of steps required for the valve assembly on the manifold. He starts by reviewing the instructions to determine the placement of the termination bolt. He then executes this instruction. He reviews the placement for the electrical air valve, then aligns the air valve on the manifold block for assembly. He reviews the instructions for securing the electrical air valve, then performs the step of fixing the valve to the manifold block. The control characteristics for the torque requirements were included in the CAD model and have flowed through the process plan and work instructions all the way to the connected tool at this work cell. And here you can see the actual torque value has been captured and validated against this requirement. When the operator confirms the step, the torque value is recorded for digital product traceability. After completing, capturing, and validating the remaining steps for the manifold procedure, the assembly can now be passed to quality inspection. In this demonstration, we have seen how information flows along the digital thread from engineering to manufacturing. First, we saw how the MBOM and process plan were updated to reflect the CAD and EBOM changes which resulted from the change notice. We then saw how updated digital work instructions reflecting the new process plans were automatically delivered to the operator in the context of his assembly work at his connected work cell. Torque values and other key metrics were captured and validated as part of the steps to ensure that the product met quality specifications.